Welcome to the U of A. I'm in front of the ECE building, and I'm with the PACT-2022 Summer Research Program, and PACT also stands for Proactive and Cybersecurity Training. And our group's research focus this summer is adversarial machine learning. And what that is, I'll get into a little bit later. However, let me introduce myself. My name is Derek Lee, and my major is systems engineering. And I really enjoy engineering because I really like the big picture part of it, and also how software and the physical aspects of engineering kind of converge together. I joined PACT because I really wanted to get some hands-on experience that I wouldn't normally be able to get inside of a classroom.
Hey, my name is Monique Hoswood, and I am a student at Navajo Technical University, and I'm majoring in information technology. I joined this program to broaden my knowledge on cybersecurity and to also be a more proactive team member.
My name is Cody Smith. I'm studying for electrical engineering at the Navajo Technical University, and I'm interested in cybersecurity for my degree.
Adversarial machine learning is the understanding of the security side of machine learning. But let's take a step back and understand what machine learning really is. Machine learning is being able to take any data set and be able to train the algorithm to be able to predict potential future outcomes. I think the best example I could give is be able to analyze past stock market trends, or be able to look at a bunch of banking transactions and figure out which ones might be irregular, which ones are normal, to be able to catch frauds, or the last ones being able to classify objects, especially with self-driving cars.
Machine model learning is developed using these steps. The first one, data acquisition, is the process that involves taking a sample of something and converting it into a digital value. Pre-processing is to collect the data, analyze, and filter to ensure that it can be used in a beneficial way. Feature extraction is performed on a large number of variables to reduce the amount of raw data and manage into groups for processing, for example, turning the data into matrices. Feature selection. This allows you to select various features that contribute to your output on your prediction variable, for example, X and Y. Model selection and training. Finding different types of classification models and training it with our datasets, for example, the decision trees. Evaluation. The process of model evaluation is to measure the quality of a system's predictions.
There are 4 attacks in machine learning: model extraction, Byzantine attacks, evasion attacks, and data poisoning. In our group, our main focus is to analyze network data and data poisoning. We want to be able to differentiate normal behavior from irregular. We've been tasked with network training data that has 1,000 label samples to train our supervised machine learning algorithm that has been able to classify poison data.
We are all fairly new to Python, and so we were given a small Python assignment as a refresher course. This helped us with the basic fundamentals to some of the Python libraries that we'll be using. We were then provided with the 3 CSV files that included features, training, and testing. Most of the part was us trying to be familiar with the data and also manipulating our data. After that, we implemented Pandas, NumPy, and PyLab to generating our data, in which case we loaded our training data and testing set into our data environment using Google Colab and Juniper notebooks. We started using scikit-learn to perform standardization of our data, to which our data is being scaled onto one model. We continued using scikit-learn's various Bayes estimator algorithms, to which we used about 3 different classifiers to see how our results improved. This built a confusion matrix to analyze accuracies and errors for each classifier. PCA, Principal Component Analysis, is a method that allows us to walk around our data to find the ideal view. It does this by rotating the axis in a way that the new axis coincides with the directions of the highest discrepancy. We utilize Pickle to help serialize and deserialize objects to separate our machine learning program.
Outside from this project, we especially want to thank all faculty for their dedication in our learning. We also wanted to thank Dr. Gregory Ditzler for him. He was instrumental in leading us through machine learning. Kurt Landeman, he was an amazing ham radio instructor and led us through the ham radio technician license. And most importantly, we want to thank the Department of Energy for allowing us to continue our research here and dedicating their time and resources for our learning at the University of Arizona. Thank you.